Hiya, welcome to the third part of the Programming with RobotC tutorials. Today we're going to go over using joystick controls, and I'll probably go over a little bit on using tasks so we can do multitasking, do several things effectively simultaneously. So let's get started. Just open up RobotC. Right. Right then. So if you open up what we had open last time, we'll just build on that. Okay. So let's first do using the joystick first. So unfortunately, I haven't actually got access to the joystick or robot at the moment, as with the previous videos. But I'll show you how to do it, and hopefully it'll work. If not, then obviously just drop me a comment and I'll review it and see why. So what we can do is let's just start from fresh. You can start a new document if you want, but you'll have to set up your motors and everything. So what we're going to do is we're going to have to use one of these commands, which I can't remember what it's called. No, it's not that. Right, first we've got to include the file that has all the include joystick.c, I believe it is, joystick driver. Right, so this contains all of the commands and using the joystick basically. So if that wasn't the right. I've forgotten what the thing is. Get joystick settings, joystick. There we go. Right. So now we've used this line. This is this function which is included in the joystick driver file. This will get all the joystick settings, all the positions of the axes and the buttons pressed and everything, and it will store it into accessible variables and things. So what we can do now is, okay, let's start off by detecting if a button's been pressed, and then if the button has been pressed, then we'll do something. So if joy1 btn, this little variable has that gives us access. Yeah. So we can now in the brackets use the buttons number. If you have a look on your joystick, you'll have all the numbered buttons, and this here is where you put in your numbered button. So we got the 4 buttons on the right, 1, 2, 3, 4, and then the little triggery things on the back. They've all got numbers, and everything's got a number, and this is how we reference them here. If joystick control, I'll show you here. These are all the buttons. If you've got your joystick connected, you'll be able to press it and it will show you what buttons are being pressed, and you can use that. And unfortunately mine's crashed because I'm not connected to a brick, but that's how you get onto that. You can also read the values of the actual, what do you call them, analog sticks. Right, let me just open up that again. Right, so now if I've lost that. If joy1 button 1 equals 1, what this equals 1 thing does is it checks if it's true. You could probably use true there instead of 1, but I always just use 1 just for simplicity. So this checks if this button has been pressed, then we can run the stuff to do something, say change the speed or something, etc. Then you can also do, what you can do is have many of these. So if button 2's been pressed, then we want to, I don't know, move the arm. You see how I'm going with this. You can just string many of these together. If 5's been pressed, then do something else, etc. And you can just string them together like this. But as what will happen is when this is run, it will run through this, and then when it gets to the end, it will stop. So what it's going to do is it's only going to check this once, because it's going to run through this once. If any of them happen to be pressed, it will do that, but then it will just stop at the end. So we're going to need to make it loop through this, well, probably infinitely. So what we're going to want to do is use a while true, and then so while true, so that's going to be always. It'll forever loop through this. So it's going to update the settings, check if any of the buttons have been pressed, do the stuff, and then loop through again and again and again, and it will continue looping through this again and again and again. So let's just start off. Let's just say we've got a void of change speed. So as last time, we'll just create a function, say change the speed equals 20. I haven't actually got that as a, so we'll say when button 1's pressed, we want to change speed. So that should compile okay, yep. So that's one way of doing things, but if we want to be able to do two things at the same time, so let's say you've got 2 joysticks in the actual competition, so one will be, let's say one's moving the robot and the other one's controlling some sort of arm or conveyor belt or some other implement you got on there. So you want to be able to move with one joystick and control an arm with another joystick at the same time. Now if we just do it like this, and let's say what we'll do is joy 2 button 1. So this will check if button 1 on the second joystick's been pressed, then we want to move forward or something. You want it to be able to move forward and move the arm at the same time because they're 2 separate joysticks. You want to be able to do that. So what we can do is create a task. Now a task is different from a function because first of all it is void, it doesn't return anything. But when a function is run, when it gets to here, it runs the function and it waits for the function to finish, and then it will continue. With a task, it will set the task off going and then it will continue. So if we have what we can do is it's very similar. As you can see, we've got a task here called task main. So let's say we've got a task move forward. And then this will do, let's say this does a whole bunch of things. It goes on for ages, blah 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 blah. Does a load of stuff. Takes ages to run it. And we want it to be doing this while checking all the other stuff. So this task enables multiple things to be happening at the same time. So if we change this to a task, what we want to do is you don't call it the same as a function, you call it by running start task and then the name of the task. So what this does now is it will run this task when it gets to here, and then it will continue. Even while this task is still being executed, it will continue. So if you've got 2 separate tasks for your joysticks, 2 separate joystick operations, so it can be, because it will be still looping through here, if the first joystick button's been pressed, it will be changing the speed or whatever here, moving the arm or doing whatever you've got, and then it can also be moving forward at the same time. So this enables multitasking, which is very useful because you don't want to be, you've got 2 controllers, so you want them both be doing things at the same time. It's pretty obvious that's what you want to be doing. because without that you'd be forever having teamwork issues. You just like getting one person to stop and then the other person to stop, and then so if you do it with tasks, that's the best way of doing it. Now, there are some limitations with using tasks. You can only define, so by doing this, a maximum of 20 tasks. So you don't want to be using, if you've got more than 20 things you want to be doing, you've got to compromise between whether you need it as a task or whether you can get away with it being a function. So if it's only something small, like changing the speed, you could get away with using this as a function because it only takes milliseconds to run through that. It's not going to have an effect on whether the operation of your robot. So, but for moving, that's a bit more of a sort of a bit more of a longer process. So that's something that you'd want to be done as a task. So I'll show you how we've sort of done it. What we've got is, I've initially got as many things as tasks as I can, and then the rest of them using functions. So I've got tasks for rotating and tasks for moving. This is definitely going to be a task because this is a very long. Oh, also this is actually another infinite loop. So that's another reason why you'd use a task, because if you want to infinitely loop through something, and you've also got another infinite loop. So we've got an infinite loop for checking the joysticks, but I've also got an infinite loop of checking the joystick coordinates of the analog stick. So I want these two infinite loops to be running simultaneously. So we've got them in two different tasks. So as you can see here, I start the joystick listener task, and I've commented this out because of testing, but I've also got another task running at the same time. So that's you can have two infinite loops running at the same time, pretty much simultaneously. So that's a very useful feature of using tasks, because you'll soon pick it up and realize the possibilities of using tasks. So that's pretty much it. You can use this little reference here for any of the button numbers. This one, if you've got for the second joystick. But I'll quickly go over using the analog sticks. So the direct D-pad. So using the D-pad is a little bit different because they're not numbered, isn't it? Well, it's not numbered as the same way these ones are. But we use this reference here to access it's called the top hat on this, but it's the directional arrows, the 8 directional arrows. And each direction is numbered from the top, so forwards is numbered as 0, and then the diagonal top right is numbered as 1, and then it continues round clockwise, increasing in 1 so each time. So if you want to go, so the directional pad right is labelled 1, 2, 2. Down is labelled, I can't remember what it is, 4, 5 or something. Anyway, I think that's on this joystick control panel, but I can't do that because I haven't got it plugged in. But what we want to do is, instead of referencing it like that, equals 1, it's just that equals 4 for the button number 4 on the D-pad. And it's the same thing for the second joystick, but you just replace a 1 with a 2. So it's pretty basic stuff. Missed something up. It's got to be, I think it has to be joystick dot. You could probably get away with just using joy1 top hat, but I'm not sure how well it references that or if it will compile at all. But as you can see in our actual code, we've got if joystick.joy1 top hat equals 0. So if you're pressing the forward sort of on the D-pad, it will start the move forwards task. If you press number 3, it will move diagonally back right. That's our task there. We've also got the button checks underneath it. So if button 1's being pressed, then change the speed to 20. If 2's being pressed, change it to 50. If 8's being pressed, rotate 90 degrees to the right. So that's how you use the D-pad. I don't know what you want to call it, the directional pad, the top pad, whatever you call it. That's how you use that. But you can also use the analog sticks. I found it very difficult to code in movement using the analog sticks because it was just impossible. It was a nightmare to get around. But you can see we've had to use all this complicated maths, and you can thank Josh for helping me do that because he did a lot of help with the ratios and everything. But so I wouldn't recommend using the analog sticks for movement. But if you want to if you want to use it for one-dimensional movement, so moving an arm up or down, then that's pretty simple to do. So what we can do is if we create some decimal point variables, so x, y, and then x can be, if we set x equal to the x coordinate of the first, so x1, joy1, I think I have to do joystick period. Let me just look that up quickly. Yep. So this will get the right. That gets the x coordinate of the first joystick's so left analog stick, and then we'll get to y using exactly the same, but replace x with y. So if we wanted to get the coordinates of the second analog stick on the first joystick, we would replace this with 2. And then for the second joystick, first analog stick, you see what I'm doing? So that will get us the coordinates. So then if you wanted to debug this, you could just echo this. Sorry, wrong one. Oh, I've done that all. But you see what I mean? You could, as we've done in the part 1, I believe it was in, you could echo them out to the display just so you can debug it and see all the quadrants and everything. So one thing to remember though is it's not using the same typical coordinate quadrant that you're used to in, like, say, in your maths lessons, where the top right coordinate is positive, positive, and your bottom right is positive x and negative y. It's not like that. It's been inverted. It's been, I can't remember what it is. It's been flipped along the x-axis. So you'll have to have a play and sort of get that into your head. Use the joystick control panel, and it shows you the coordinates. So if you just push it all the way to the top left, you'll see that in the top left, both of the coordinates are negative. So unlike what you would expect it to be, having a negative y and a positive x. So it's been, what you can do to get around that is if you times the y coordinate by -1, that will now reflect the proper, well, the I don't know what you call it, the fundamental quadrants that you're used to. So correct me if I'm wrong with that, someone, but that's what we have done. Yeah, look, we just times it by -1 straight away, just so it inverts the y coordinate. So that may be something you want to do. If you don't do that, then you'll have to program around it. But then you can check if the x coordinate is greater than 20 and the y coordinate is greater than 30 or 20, then move the arm up or something. Actually, you don't need to check the y coordinate for that. Then move the arm up, move up. Else, if the x coordinate is less than 20, then move down. Something like that. It's nice and easy to do. It's pretty simple. If you don't understand that, it's just let me know, because I'm not the best at explaining these things, and I may have to go over this again. But that's the basics of using the analog sticks. So what else have we done that I could show you? That's pretty much it, I think, for joystick control. So I'll sum up the commands. Remember to include the driver. That's number one point on why they don't work. You haven't got your driver included. Then you also make sure you're in an infinite loop by using while true or while 1 equals 1 or something like that. Just make sure you're in an infinite loop. Make sure you get the joystick settings, and then you can use any of these joy 1 button 1 equals 1 or button 2, or yep, that's how you do the buttons. The D-pad is referenced like joy 1 top hat equals 4 for button number 4 or 2 for button number 2, and your analog sticks are referenced like joystick.joy1 underscore x1 or x2 or y1 or x or y2 or sorry, that should be joystick there, not just joy, or joy2 for joystick number 2. So there are your joystick commands, and also how tasks work. So a task, you could, if you wanted, set up a task called your joystick listener. This is what we've done. We've got a joystick listener task. Put all of this in. We put all of that in our joystick task, and then in our main task we just start the task of the joystick listener. So that just separated it out. And then you don't. This here we just use for debugging purposes. But that is the basics of using the joysticks. So also, I'm not sure if you're aware, but these here are comments. So the compiler actually ignores them, but it's a way of documenting your code, what works, or you can use them to debug things by commenting things out, and so it's not run. But you can do multi-line comments like that. So there's just a quick overview on that. Of course, if there's anything else that you want me to cover, just let me know. But this will probably be the last tutorial, because there's not much else we can actually go over. Not much in the way of what we've done. There's a couple more. You should know these data types and things, because that's just basic programming knowledge. Of course, you can go over to cprogramming.com, which is a very useful website. I mentioned it, I think, in the one of the last parts, but this will give you a basic overview on C. So if there's anything you don't understand that's not specific to RobotC, then look it up on there. Else you can use the RobotC help by pressing F1. You can there's basically everything. This is how I learnt it, from the help. Just if you wanted to move a motor, you can just do a search for motor. And then this shows you all the different commands and how to use things. Encoders. I'll make another part on encoders, because that's another sort of. I'll also go over setting it up, and I'll probably do a little video of attaching an encoder onto a motor, because that's quite fiddly. So I will do another part, and I'll also do a setting up Samantha and FCS part. But that won't be till sometime in the new year, when I'm actually with the robot. But yeah, that's about it. If you need any help with anything at all in RobotC, just give me a YouTube inbox or comment or Twitter someone, and we'll get back to you. You can I'll put my email address on the screen here as well at some point, so you can email me if you really want to. But that's about it. So next time we'll go over using an encoder, and then I'll do a couple of videos about Samantha, because that's been a pain in the arse for us. Constant source of problems, Samantha. But so I'll do videos on the workarounds that we've had to use for that. Also, I'll just go over quickly. If you're using a Mac computer like I am now, you'll have to actually run RobotC in a virtual machine or use Boot Camp. So there's plenty of tutorials on YouTube and across the internet how to do that. But if you've got a technical mind and you know what wine is, you're not going to be able to use that for RobotC because it interfaces with the USB and the hardware too much. So you're going to have to run it through a virtual machine, unfortunately. But that's the basis of that. Of course, yep. Message me if you need help. Thanks for watching, and I'll see you next time.